Hey guys, today we're going to learn how to write equations for parabolas in Vertex Form as well as work through a couple word problems that deal with parabolas. So we know that Vertex Form is y equals a x minus h squared plus k, where your vertex is given to you as h comma k. So we're going to go through, take these two equations, these two parabolas, and write the equation for them. When you're trying to write the equation for parabolas in Vertex Form, you have to know two things. You have to know where your vertex is, as well as a point that's on the parabola. So vertex is always going to be either the lowest or highest point on the parabola. So for this first one, your vertex is going to be the lowest point. For the second one over here, your vertex is the highest point. So with the first one, your vertex is -2, -3, and a point that's on the parabola is given to you over here as -4, 5. So what we're going to do with that is take our vertex, plug it into our vertex form. Instead of h and k, we're going to replace those with -2 and -3. So we're going to have y equals a parentheses x minus, it is always going to have that minus there, and then we put in our h value, which is -2, and then squared minus 3 at the end. So for here, in order to solve for an a value, we have to know x and y. So that's why we need to know one other point that's on the parabola. So we're going to take our -4 and 5 and plug it into x and y. So our y value is going to then turn into 5 equals a parentheses x, which is -4. And now we have a minus followed by a negative, which makes a plus sign. So plus 2 squared minus 3. So we have one equation with one unknown. So therefore we can go through, manipulate this so that we can get a by itself. So we're going to take this 3 that's at the end, move it to the other side of the equation first. So adding 3 to both sides gets us 8 equals a -4 plus 2 inside the parentheses gets us -2 squared. So -2 squared, we know that to be +4. So to get a by itself, the left step, divide both sides by 4. So a equals 2. So now that we found our a value, we can go ahead and plug it back into our equation. So it's going to be y equals our a value, 2, parentheses x, and then we're going to have minus -2, which is going to be x plus 2 squared minus 3. So in vertex form, our vertex is going to be inside the equation, and now we just found our a value. So this equation crosses through all these points on this parabola. So we're going to do the same thing with this next parabola. So again, we still have to know our vertex, which is this dot that's at the very top, and we also have to know a point, which is this dot right here. So our vertex is 4, 1, while our point is going to be 7, -2. So we're going to do the same thing, take our point and our vertex and plug it into x, y, and h and k. So our y value, we can replace that with -2 equals a parentheses x, we can replace with 7, minus our h value, which is 4, squared plus 1 at the end, which is our k value. And then just like the last problem, we have to isolate a. So go through, add 1 on both sides, and then we know that 7 minus 4 is 3, and then 3 squared is going to be 9. So then dividing both sides by 9, we get a to equal -1/3. So from there we can take our a value, plug it into our vertex form. So it's going to be y equals -1/3 parentheses x minus 4 squared plus 1. So this is the equation for this parabola right here in vertex form. Alright, so the next thing we're going to do is go through this word problem. So Courtney is building a rectangular wading pool. She wants the area of the bottom to be 54 feet squared. She also wants the length of the pool to be 3 feet longer than twice the width. What are the dimensions of her pool? So let's draw a picture. We have a rectangular pool. and the area is given to us as 54 feet squared. We also know that we have a width and we have a length. So our width is going to be W, and our length is going to be twice W plus 3, because she wants the pool to be 3 feet longer than twice the width. So twice the width plus 3. Alright, so we can use this information to figure out what W is. So we know how to find area of a rectangle. That's going to be length times width. So W times 2W plus 3 equals our area, which is 54. So in order to solve this, we have to distribute W into the parentheses and then move 54 to the other side of the equation. So distributing W times 2W, we get 2W squared. W times 3, we get 3W equals 54. So in order to solve quadratics, we had to set this equal to 0. So subtract 54 on both sides, and we get 0 on one side. And then from here you can either go through and factor this or use the quadratic equation. So with this one I'm going to go through and factor. So with factoring you can try to do the M method. So you take the first number, multiply with the last number. So 2W squared times negative 54 to get negative 108 W squared. So we're going to break apart negative 108 in a way that adds up to 3. So going through all those numbers, you eventually come up with negative 12 or positive 12 W times negative 9W. So positive 12 times 9, positive 12 times negative 9 is negative 108. Positive 12 minus 9 is positive 3. So we're going to bring our first term down and our last term down, and then begin to group them. So the first group has 2W in common. Our second group has negative 9 in common. So then the parentheses are now both the same as W plus 6. So we can factor that out to the front. And we have 2W minus 9 equals to 0. So from here we can set each part equal to 0 and solve for W. So taking the first one, when we solve for W, we get W equals negative 6. And the second one, W equals positive 9 over 2. So when we're doing this, we have to go back and see which one of these is actually a possible solution. So we know length can't be a negative value, so that eliminates negative 6 as a possible answer, leaving our width to be 9 over 2 inches, so 4.5 inches. In order to get the length, we have to take our width, plug it into our equation. So 2 times 9 halves plus 3 gives us 12 inches. So our length is going to be 12 inches, or width is 4.5 inches. Alright, so we're going to do one more. So Kelly throws the ball upwards into the air at a rate of 80 feet per second from a height of 6 feet. The equation is modeled by f of x equals negative 16x squared plus 80x plus 6, where x represents time in seconds and f of x represents the height of the ball in feet. So we got to do 4 things. First, we got to figure out the height of the ball after 1 second. So let's draw a picture so that we can visualize it. So we have a person that's standing there. She throws the ball up in the air, it comes back down. So the first question asks for the height after 1 second. So second deals with our x variable. So we're going to take 1 and plug it into the x terms. So every single x we have, we replace with 1. So negative 16 times 1 squared plus 80 times 1 plus 6. Simplifying all that, we get 70 seconds, or 70 feet. So that means in 1 second after she throws the ball, it's going to be 70 feet in the air. Part B. After how many seconds is the ball 80 feet off the ground? So we want this to be 80 feet high, so height deals with our f of x. So we're going to replace f of x with 80. Everything else stays the same. And we have to go through and solve for time. So time is x, In order to solve for x when you have quadratics, you need one side to equal 0. So you have to take this 80, move it away. So subtract 80 on both sides of the equation, and you get negative 74 at the end. So from here we're going to use the quadratic equation to go through and solve for x. So the quadratic equation is x equals negative b plus minus square root b squared minus 4ac divided by 2a. It's up here. So we got to figure out what a, b, and c are. So a is going to be the first number, so the very first number, the negative 16. B is going to be the coefficient in front of the x term, which is 80, and c is the constant, negative 74. So we're going to take these three numbers and replace it with where all the letters are. So every b we have, we put 80, every a, negative 16, and c we put negative 74. So we're just going to go through, fill in the letters with the actual numbers. Alright, so from here we got to go through and start simplifying it. So we're going to start off inside the square root, go through, simplify all that, and we come up with 1664. On the bottom we're going to get negative 32. So take 80 squared and then combine it with negative 4 times negative 16 times negative 74 to get 1664. And from here we had to square root 1664 and break it apart. So the plus and minus sign splits up into two pieces. One that's going to be a plus, and one that's going to be a minus. So the square root of 1664 is around 40.8. We're just going to round it to the nearest tenth. And then from there we're going to go through, combine the top, and divide it by negative 32. So you get the first one being 1.23 seconds, and the second one being 3.78 seconds. Alright, so type these into your calculator. Make sure if you do it in your calculator you put parentheses in front of negative 80 and at the end of 40.8 divided by negative 32. So you have to type it in like this. So what this means is that in 1.23 seconds the ball is going to be at 80 feet, and then it gets there, and then eventually it comes back down, and 3.78 seconds from when you throw it, it's going to be at 80 feet again. So those are both your answers. Part C, how long will it take the ball to reach its maximum height? So the maximum height is at the very top of the path. Since it's a parabola, we know the very top is called the vertex. So we're going to try to find the vertex. So the formula to find vertex is negative b over 2a and f of negative b over 2a. So negative b over 2a gives us our x value, which stands for time, and f of negative b over 2a, f of x, stands for your height. So this question is only asking for time because it wants to know how long will it take the ball to reach its maximum height. So we're just looking for the x value. We're just looking for how long, which is time. So we're going to do negative b over 2a to tell us how long it takes to reach its maximum height. So negative 80 divided by 2 times negative 16 gets us 2.5 seconds. So after Kelly throws the ball, 2.5 seconds later it's at the very top, and then it starts to come down. And part D, how many seconds was the ball in the air? So when the ball lands, it hits the ground, which is called the X-Intercepts. So with this, we're going to take our original equation, negative 16 x squared plus 80x plus 6, and find our X-Intercepts. So we're going to plug in A, B, and C into it. So this time our A value is going to be negative 16, our B value is 80, our C value is 6. Remember, we're using the original equation from the very top of the problem. And we had to go through and simplify this. So again, we're going to start inside the square root. Simplifying that, we come up with negative 80 plus or minus square root of 600 or 6,784 divided by negative 32. So from here we got to break it apart. So negative 80 plus or minus, we're going to square root 6,784 to get 82, roughly 82.4. So one of them is going to be plus, the other one's going to be a minus. And we simplify that to get the first one, negative 80 plus 82.4 divided by negative 32 gets us negative 0.075. And the bottom one, we get positive 5.08 seconds. So we know time's not going to be negative. So therefore, our answer is only going to be 5.8 seconds. Alright, hope this helps.